So first I wanted to give you a basic idea of probability. In this section, we're not going to be calculating any probabilities. We're just going to be finding sample space, but I just wanted to have this brief conversation so that we know kind of what the point of finding sample space is. So one idea that most textbooks use to introduce probability is the flipping of a fair coin. First of all, what we mean by fair coin is it's not weighted, so it's not going to always land on heads or favor one or the other side. So it's a normal coin, say a quarter, with heads on one side and tails on the other. And so say I flip the coin and I want to know what the probability of getting heads is. So I'm going to flip it and I want to know the probability of getting heads. And this right here is notation for probability of heads. Okay, so P and then parentheses H or whatever you're interested in. So in this case, we're interested in getting heads. So what we're asking for is we want to come up with the chances of this occurrence happening. And what we need to know, I mean, you probably are familiar enough with probability to be able to figure this out on your own. But when we're finding probability, what we want to think of is how many equally likely possibilities will happen. What we want to think of is the total number of outcomes for the event that could occur. So the total number of outcomes or the sample space of the event. So I'm going to write the number of possible outcomes. And in parentheses, I'm going to write sample space. And we're going to divide this number into the number of events for the condition that I desire, or the number of events for the event that I desire to occur. So when we think of this problem right here, the probability of getting heads, let's just think right here in this space what the sample space for flipping a coin. I can either get a heads, H for heads, or I can get a tails, T for tails. So there are two possible outcomes. And of those events, I'm only interested in getting a heads. So that's 1. So the probability of getting heads is 1 over 2 or 1/2. You can write it as 0.5 or you can write it as a percentage. So this doesn't mean that the coin's going to land heads up once every 2 times you toss it. Yeah, so it just means like in the long run, after 1,000 tosses or 10,000 tosses or 1,000,000 tosses, the proportion of tosses that land heads up will be really, really close to this classical probability 1/2. So that's the basic idea of probability. Like I said, the point of this section is to be finding the sample space. So I just wanted to give you some background on probability. So how we're going to find sample space, there are 2 ways that I'm going to show you. I'm going to show you how to use a tree diagram. And I'm going to show you how to just list a table of outcomes, probably using a matrix. So let's start with this tree diagram. So let's go back to this coin example and say I flip a coin, this fair coin, and I flip it twice. And I want to find the sample space using this thing called a tree diagram. So this is how a tree diagram works. We have we start at one point, right here. Here's my 1 point. This is my first toss. And I list the possibilities of my first toss. So the first time I toss the coin, I can get a heads or I can get a tails. And then I'm going to toss that coin again. So from this point, I'm going to have 2 options. I'm going to have a heads or a tails again. Or if I flipped a tails first, I could still get a heads or a tails. And this is how we read a tree diagram. We read along the branches of the tree the different possibilities. So heads, heads, that's one outcome. Heads, tails, that's another outcome. Tails, heads, that's another outcome. And tails, tails. So my sample space for flipping a coin twice is heads, 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 tails, tails, heads, tails, tails. A lot of times in IB type questions, they either ask you to build a tree diagram or fill one out. So you need to be able to build a tree diagram from scratch and be able to read it and find missing pieces. So let me just show you one other example of a tree diagram. Say I have a box. Okay, say I have a box, and in this box I have, what should I have in there? Maybe different marbles. Okay, marbles, that's a very classic probability type thing. I don't know why people have urns or boxes with marbles, but we use that a lot in the teaching of probability. So say in this box I have 2 blue marbles. I have 4 red marbles, and I have 3 white marbles. And I want to know, and I just want to find the sample space for the event of drawing 2 marbles. So I want to know the sample space for drawing 2 marbles. And when I draw these marbles, I'm going to take the marble and then keep the marble. I'm not going to put it back. So doing a tree diagram, we'll just start with my first pick. So with my first pick, I can get a blue marble, I could get a red marble, or I could get a white marble. And then when I pick a second marble, again I can get a blue marble, a red marble, or a white marble. If I picked a red first, I could still get a blue, a red, or a white. And if I picked a white first, I could still get a blue, a red, or a white. So my sample space here, I'm just going to read it like this: BB, so blue, blue, BR, just reading along the branches, BW, RB, RR, RW, WB, WR, and WW. So there are 8 different possibilities. So the other way I want to show you to find a sample space is coming up with a table of outcomes using a matrix. So another classic probability type problem is the use of a die. Okay, so a 6-sided die, and so I hope you're familiar with dice, but the dots on the sides are between 1 and 6. And so say I rolled 2 6-sided die, or 6-sided dice, and I want to know the sample space for rolling those 2 dice. So I could do a tree diagram. I could just do it all in my head and just do a list form, because I know, if I roll one die, I could get a 1, and the other one I could get a 1. Or I could roll 1 with the first die and then 2 with the second one. So I could just list all the possibilities, but I wanted to show you a matrix and what that looked like. So I roll the first die and I can get a 1, a 2, a 3, a 4, a 5, and a 6. And then I roll the second die and I can get the same thing, a 1, a 2, a 3, a 4, a 5, and a 6. And so this little chart here is going to help me organize all the different possibilities. So I can roll the first one and get a 1, but then roll the second die and get a 2. And then I can roll the first die and get a 2, and the second one and get a 1. I can roll the first one and get a 3, second one and get a 1. You see where I'm going here. So I'm just going to, whatever column I'm in, I'm going to write that number down. Whatever row I'm in, I'm going to write that number down until everything is totally filled out. And then I'll know what my sample space will look like. Okay, that's it for video 4.1. There might be some problems involving playing cards, so if you're not familiar with a standard 52 card deck, just let me know and we'll go over what is in a deck, what is in a 52 card deck. Good luck on the practice problems and let me know if you have any questions.